Alright, so this is the math section of the first practice test from the official ACT guide from 2016 to 2017. And the first problem, unfortunately, there's no special technique or quick trick we can use to make it easier for ourselves. We just have to expand and combine like terms. And so we have 4a minus a squared minus 5a minus 35, and we see that there are two like terms we can combine here, the 4a and the negative 5a, which combine to become minus a minus 35, and this matches up with answer choice C. For the next question, we have to compare different numerical values, and the trick here is to convert all of them into the same format. So since two of them already are in decimal form, the easiest thing to do here would be to convert this fraction into decimal as well. So let's just write out all of our available options in decimal form. And to find the decimal form of 1/4, you might do it mentally, you could use your calculator. Whatever you do, the main aim here is to have all the numbers converted into the same form to make them easier to compare. And now we're going to order these from least to greatest as the question asks. So we have 0.03 as the smallest, and then we have 0.2, and finally we have 0.25. But we're not done here. The key thing to remember is that once we've converted them into something that makes it easier for us, we have to remember to convert back into the form that the numbers were given to us in. And so since these two are already given to us in decimal form, there's no work for us to do there. But we do have to remember to turn this 0.25 back into 1/4. So when we convert it back, we have and this order matches up with answer choice G. Number 3, when you look at number 3, it seems like what we should be doing is solving for x with this equation and then plugging that into this expression and finding out what the answer is. But that's the inefficient, longer way of doing it. The quicker way of doing it is to take this equation and manipulate it so we have x squared minus 4 on the left side and some kind of number on the right side. So let's take what we've been given, and we're going to get rid of the 4 by subtracting 4 from both sides. And then we're looking for an x squared minus 4 on the left side, so we're going to subtract 4 from both sides again. And what we're left with is that x squared minus 4 is equal to 21, which matches up with answer choice C. Now we used a quicker technique here to get our answer more easily and with less time, but it is important to know how to do questions more than one way. So you do them one way on your first pass through the question, and then when you're coming back to check your answer, you can use a different method to confirm that your answer was right the first time. In this case, the second method would be the longer time-taking way of solving this equation for x and then plugging that in here and confirming that we do get 21. So in number 4, we've been given the coordinates of a rectangle, and what we want to know is how much of the rectangle is in quadrant 3. So what we're looking for is a fraction of the form quadrant 3 over total. And so what we could do is plot all the points we've been given, and then look at the rectangle in the graph, and then look at how much of the rectangle is in the third quadrant. But what would be a lot quicker is if we found the total area by looking at the coordinates and finding the dimensions. So 4 minus negative 1 gives us a dimension of 5, and then negative 2 and 3, the difference between that is also 5, so our rectangle is actually a square with the dimensions of 5 by 5, which means that the total area is 25. Now all we need to do is find out how much of that rectangle lies in quadrant 3. So the edges of a rectangle in quadrant 3 are these parts of the axes. So all we need to do is find which point lies in quadrant 3, which is negative 1, negative 2, so right here. And you can see that this rectangle, bounded by the negative x-axis and the negative y-axis, has an area of 2 units. So, final answer is 2 over 25. You can either multiply this by 4 over 4, or you could use your calculator to find out that 8% of the total area lies in quadrant 3. In our next question, we have a starting price of clothing in 1985, and we know that this cost goes up every year by some amount X. We don't know what that amount is, we need to find out. So, it started off at $620, and then 10 years later, it's $1,000. So 10 times some rate X, which is how much it increases every year, gets us to $1,000. And so X here again is the rate, or how much the price increases every year. And you can use your calculator to subtract 620 from both sides and then divide by 10. And the final answer, or rather one step on our way to the final answer, the rate is $38 per year. So every year the cost of clothing goes up by $38. And so what we're looking for is the cost in 1991. So that we need to know that that is 6 years after our starting point of 1985, which means that the price will have become 620 plus 6 times 38. And again, you can use your calculator here to simplify this expression, and it ends up to be $848. In our next question, we have a certain number, and since we don't know what that number is, we're going to call it x, and the square root of x is equal to 9.2371. And what we're looking for is what x is between. Now, one way of doing this is to square both sides and then get our answer. So we could plug 9.2371 into our calculator, square that, get another number, and then look at these ranges here and find out which range our number fits into. But you can save time here. You don't need to sit there and plug this number into your calculator exactly. You can use estimation. You can round this down to about 9, and then what we have is that the square root of x is about 9. And when you square both sides, that's something you can do mentally. So x would be about 81. Of course, because of this decimal, we know that in reality, x is something more than 81. But either way, x fits into this range. The last problem on this page is a probability problem, where we're looking for the probability that if we pick a candy randomly, it is not grape flavored. Now, there's two different ways to do this. The quickest way is to find out what the probability is that we do get a grape-flavored candy and subtract that from 1. So what we get is 1 minus 2 over 10. The other way of doing this, which you could use as a checking method, is to add up all the numbers that refer to flavors besides grape. So 1 plus 3 plus 4, which is 8, and that would be your final answer. Either way, you get to the same number at 8 over 10, which simplifies to 4 over 5. In this next question, we're given one endpoint and the midpoint of a line segment, and what we want to do is find the other endpoint. Now, we could plot the points that we've been given in this coordinate plane, but the easier thing to do here is to realize that we're using the midpoint, and the coordinates of the midpoint of a line segment are the averages of the coordinates of the endpoints. So, if we call point A, and we refer to it as A sub x and A sub y, and we refer to point B as B sub x and B sub y, the midpoint's coordinates would be A sub x plus B sub x over 2 and A sub y plus B sub y over 2. We know the coordinates of B, so we know what B sub x and B sub y are, and from there it just turns into an algebra problem. So we have A sub x minus 3 over 2 is equal to 1, since that's the x-coordinate of the midpoint. And similarly, we have A sub y plus 4 over 2 is equal to 2. since that is the y-coordinate of the midpoint. And if you solve these, you get a sub x minus 3 equals 2, and a sub y plus 4 is equal to 4. So a sub y is 0, and based off of that, we can choose answer choice K. It's important to note that you don't actually need to solve both of these. Solving just one of these is enough to get to the right answer. Now our next problem is another algebra problem. We have a company that currently has 116 customers, which is 8 more than twice the number it had 1 year ago. Now the main issue here is translating from words into numbers. So if we were to translate this word problem into an equation, we would have 116 is equal to 8 plus 2 times x, where x is however many customers they had 1 year ago. And what this question is asking is simply the value of x. So we subtract 8 from both sides, and then following that, we divide by 2. So we get 2x is equal to 108, which means x is equal to 54, which matches up with answer choice B. Again, for number 10, it's yet another algebra problem where the main issue is translating from words into an equation. Joseph will have a 200-foot long fence installed around his yard. There's a fixed fee of $500, so we can treat that as a constant plus a set amount per foot of fence. We don't know what that set amount is, as you can see from the last sentence in the question. We know that this rate is per foot, and since there's 200 feet that Joseph is installing, we can add that as a coefficient of the rate, which again we don't know and we're trying to find. The total we have is $2,200. And from here, it's simply a question of isolating x. So we get 200x is equal to 1,700 once you subtract 500 from both sides, and then when you divide both sides by 200, you find out that x is equal to 8.5, which matches up with answer choice H.